Hi, let's go through the resistor comparison lab. Here are 5 resistors. Notice each has 4 color bands. 3 seem to be grouped together at one end, and the 4th all by itself at the other end. Let's call the first resistor, the one at the top, A. It has a brown, then a green, then a brown stripe. That's on one end. On the other, it's a little hard to tell, but there's a gold band. The second resistor has a brown, a green, a black, and yes, it's a red stripe at the other end. Brown, green, black, red. Let's call that resistor B. The middle resistor has a red, black, that's 3, and then at the other end, a red. Let's call that resistor C. The fourth resistor has 2 orange bands and then a black, and at the other end, a red. So it's orange, orange, black, red. We'll call that resistor D. Finally, the fifth has a brown, 2 blacks, and at the other end, I know it's hard to see, a gold band. That can be resistor E. Brown, black, black, gold. We're going to put 2 D cells into N to form about 3 volts of potential difference. And add a bulb and a place for a resistor. Can you see it? It's lit up. With resistor E, it lights up. With the other 4 resistors, the bulb doesn't light up. Nope, doesn't light up. Resistor E is the only one that makes the bulb light up, and it only lights up a tiny bit. Now we're going to add another D cell in series to make 4.5 volts of potential difference across the resistor. This time, the bulb lights up with resistor B. Can you see it? I know it's a little hard. But it doesn't light up with any of the other 3. That is, it doesn't light up with A, C, or D. Nope. Doesn't light up. Let's use a 9-volt battery next. Look at C, how bright it is. Now, how about D? It lights up, but not as brightly as C. Let's go back and take a look. Quite bright. And back to D. Not as bright. And now A, the last resistor, A, well, it doesn't light up at all. Stop the video. See if you can sequence the resistors from least resistance to most resistance. Then, after you've done the sequencing, come back and learn about the color code. All right, 4 colors on the resistor. There's 3 on one end and a 4th at the other end. In this case, it's orange, black, brown, gold. All right, here's an example. Yellow, I guess it's violet or purple, brown, and gold. The first 2 color bands are about digits. First digit. We have a yellow. We go down, that's a 4. We have a violet or purple, that's a 7. So we write those 2 digits down, 4, 7. The third is a power of 10 multiplier. In this case, brown means multiply by 10 to the first power. We end up with 470 ohms. The unit for resistance is ohms. The 4th band tells us about tolerance. It's not possible to make it exactly a particular value for resistance. It's always going to have a plus or minus to it. The 4th band tells us about the plus or minus. For a gold band, we know that it's plus or minus 5%. What does that mean, plus or minus 5%? Well, they're promising that it will be at least 95% of 470. So 0.95 times 470, that's 446.5. And at most, 1.05 times 470, or 493.5 ohms. So what they're promising with a gold band resistor with a nominal resistance of 470 is the actual resistance will be between this minimum value and this maximum value. Okay, back to the orange, black, brown, gold resistor. The orange looks like it's a 3-digit. The black is a 0-digit. The brown is times 10. So we have 30 times 10. That makes 300 ohms. And the gold band says it's plus or minus 5%. That's all for now, folks.